Okay, good morning. Wow, that's an impressive room. So first of all, are there people in the audience who don't speak German? Yes? Okay, so I continue in English because obviously I'm German and a German speaking to Germans in English. But yeah, welcome our international audience. That's great. So my name is Thomas Steiner. I'm a solutions engineer at Google. And today I'm here to talk about progressive web apps, and in particular, the case of www.code.talks.de. Let me start with a couple of questions. Who has never heard of the term progressive web apps? Okay. Who has a basic understanding of what progressive web apps are? Okay. And who has actually already built a progressive web app? Cool. Please come on stage later. All right. So that's just a couple of people, but yeah, hopefully after this talk today, you are encouraged to start building one. Yeah, I could have gone with like the generic example, but I decided, well, this is all about Code Talks, so let's use Code Talk as an example. Code Talks, if you look at it in the browser, and if you activate Chrome Developer Tools, looks like that. So that's your standard website. I mean, I went to the schedule because this is probably the page that most of us will consult during the entire day and get a feeling, well, what's up next? Which room was it again? Who's that speaker? So that's a page that I guess a lot of us will frequent, yeah, quite some times during the days, today and tomorrow. So yeah, I just started looking at it and seeing what could I do there. So I'm a mobile engineer recently, so I started looking at a lot of the performance things on this web page. And let's start with things that code.talks.de does very well. I was very, very surprised to see that the entire page is on HTTP 2. So that's pretty amazing. And yeah, that's really, really cool. And yeah, I guess most of you know HTTP 2 is the future. Huge performance improvements in general over HTTP 1. So all our old school hacks like CSS sprites and stuff will be mostly gone. So not completely gone, but I guess mostly gone in the future. So applause for HTTP 2 here, that's great. Also, the entire page is HTTPS. And I guess this actually deserves a round of applause. Because HTTPS is the future, it's secure, and yeah, everyone should be using HTTPS. And yeah, thankfully, Code Talks are using it. The page also itself, so the program, is reasonably small. So you can maybe see this little green box at the bottom here. Just 16 requests, 405 kilobytes. So that's pretty small and yeah, optimized for just the necessary things. So these are the things that code.talks.de does well. So where there's light, there is some shadow. And huge, huge, huge disclaimer, none of the following is criticism of any of the amazing people behind Code Talks. So let's just give another round of applause for everyone who was involved in organizing this conference. And especially the webmasters who built this website. So this is by no means a criticism of the work you have done. It's amazing, it's great. It's encouragement of things to look at for the next time. So please, please, please don't get this in the wrong ear. So the thing is, something that code.talks.de could do better is deliver. I tested this yesterday on an LTE network, so not 3G, not 2G, LTE. And it's a bit small, but maybe you can see it. My first paint was after 4.2 seconds. So that's a considerably long time on an LTE connection to stare on a widescreen until something meaningful paints. And Then after 5.92 seconds, there's the first meaningful paint, meaning there's text, something that is more than just these green boxes. If you look a bit closer here at the waterfall, we can see there's this huge initial load time of the document. And yeah, this is a bit concerning, so I was wondering, what might there be going on? Something that the page could also do better is cache. Because if you look at here, the red boxes, this is where the cache headers should be, but there aren't any. And if you look a bit closer, there's the CSS, there's another CSS, there's the logo, there's the main application JS, there's some other script about the talks, there's some other CSS. Well, this is actually not from code.talks, but if you go down here, these are the web fonts, the icon fonts. So everything that is from code.talks is without any meaningful cache header, or without any cache header at all. So yeah, that's kind of bad because the browser doesn't really know what to do with it, and it means the browser has to go out to the network every single time. And also something that code.talks.de could do better is it could work offline. Because, well, I was preparing this presentation mostly on a train yesterday, and yeah, you know how train Wi-Fi goes. It's there, it disappears, it's there, it disappears, it's flaky. Some engineers at Google have coined the term Li-Fi, so sometimes it tells you it's there, but it's not. I was tethered to my phone, so they're the same. Sometimes you have 1 dot LTE, so there should be something, but there wasn't anything. So yeah. What you have is, well, the cute offline dinosaur, but yeah, it's probably the most hated animal in the world. So yeah, there it is, the offline dinosaur. So yeah, we at Google deliver a lot of mobile speed audits to our customers. So I actually just did one for code.talks.de to address the first problems, so the speed problems, not the offline problem. I will deal with this later on. So the next slides that you will see are part of yeah, an actual speed audit, how we would run it for some of the big brands in the industry that happen to be customers of Google. So it's a tool that yeah, generates HTML5 slides. So what you see here is a static dump. But yeah, I have highlighted the core parts. So essentially, what it does is it takes the PageSpeed Insights tool, some of you may have heard it, and converts that into slides. So that's why the tool is called PageSpeed in Slides. And yeah, it just uses this and yeah, runs a couple of tests. And when we deliver speed audits, we obviously use a human audit as well, but machines can always help because machines can do the stupid tests that are just cumbersome but not don't require any intelligence. So that's a screenshot. Well, you've seen probably the page earlier. And then the tool looks at request statistics. So the requests that the page makes that are outgoing to get some yeah, data. And you can see here the breakdown, 10 static requests, 5 JavaScript requests, and 3 CSS requests. So that's not crazy. It's a smallish page, as we've seen earlier. The outgoing data, so that's outgoing, not incoming, was 2.56 kilobyte. So that's fair enough. More interesting are response statistics. So if you look at the entirety of the page, what comes down, we can see here it's yeah, pretty evenly split. So we have 202 kilobytes of JavaScript. So that's after gzipping. Gzipped is less. Then 183 kilobytes of CSS, 138 kilobytes of HTML, and then some other things that may be web fonts and stuff. So 127. So yeah, that's not overly crazy. So after decompressing, 680 kilobytes. So no alarming signals yet. That's completely normal. The PageSpeed Insights tool gives you a score that ranges from, well, I think 0 or 1, I don't know where it's based, to 100, and 100 is best. A lot of people interpret a lot in these scores. I certainly don't, at least not that much, because it's a machine. So the machine has no idea of how, as a human, we would perceive the page. Would we perceive it as fast loading? Are we staring at just green boxes, or are the green boxes already meaningful boxes that have text? So that's why in this tool, the score is not as prominently featured as on the website. But yeah, the score was 53. So looking at what was going on the page, well, you can see here, there's a lot of render blocking, JavaScript, and CSS in above the fold content. And so I've opened some of these. So it's, as I said, an HTML5 slide deck, so everything is interactive. And yeah, what you can see here, well, the first resource is the pretty big CSS file, 171. Bootstrap, and yeah, in the actual tool you can scroll down and look at what else is in there. So this is beautified and syntax highlighted. So in the original page it may be uglified, but this is beautified and yeah, as I said, syntax highlighted. So there's a huge CSS resource, and then you will notice here there's Google Fonts. And I always tell my customers, well, this is how neutral this tool is. It says, well, the Google Font Loader is render blocking, so it's criticized. We make no exception and say, well, because Google is criticizing Google, that's perfectly fine. So this is a render blocking one, albeit a pretty small one. And then we have another one, assets, page specific, talks, la la la. And then you can see here that's the actual CSS that the page uses. I guess everything up here is just Bootstrap to get, well, sort of a CSS reset. And there's this tiny thing down here that most people don't see at the first sight. There's this blue bar and then a couple of gray bars. That's each of the rules that the tool has detected. And the length of the bar tells you about the relative importance of fixing this issue. So you can see the first two rules are pretty large, and then everything else is a lot less big, meaning if you fix the first two big ones, then you have already addressed a lot. So this is the first problem, and render blocking JavaScript. The second problem is reduce server response time. And if you remember, the first initial load of the document was this huge bar where just nothing happened because the initial document was just being downloaded. And the thing is, for some reason, the server reacted only after 2.3 seconds. Sometimes it was even more. And yeah, this is not the network, this is just the server. So I'm not sure what is going on there. Maybe it's hosted by a Raspberry Pi. No idea really. So, but anyway, the server took a long time to respond, and this obviously ruins your performance. So typically, it should be within milliseconds that you get the data back. I'm not sure what is going on there, so probably some of the backend engineers could have a look at it. And yeah, I don't know. That's just something that I could repeatedly see. And this is obviously a huge problem because this is independent. You have LTE, but you just have to wait for the server to respond. So there's no way that with a faster connection, you could speed up your download here. So that's a huge problem, obviously. Then we have compression. And interestingly, if you look at the numbers here, you could save 122 kilobyte, so 88%, by using gzip compression on the core, in this case, program.html file. That's huge. So for some reason, gzip compression was not enabled on that server. HTTP2 was enabled, but yeah, gzip compression wasn't. So you can see this is a huge performance increasement just by activating gzip. And then we've talked about that earlier, browser caching. So none of the code.talks resources made any statement about cache. So you can see here expiration not specified. And this is consistent for everything, for the scripts, for the styles, for the web fonts, for the images, and then a couple of external scripts. So again, we criticize Google Analytics because it only has a 2-hour cache time here. But yeah, again, this is because there are just some best practice recommendations. Obviously, some of the recommendations don't always apply, but in general, there should be some cache expiration, somehow defined, specifically for things that don't change a lot, like, for example, the web fonts, the icon fonts that would probably stay static most of the time, or if you need to change stuff a lot, and you can see they actually did that, you can also timestamp your URLs here, so your file names. So in theory, what you could do always is just say, keep this in cache as long as possible until the end of time. And if for some reason you need to break the cache or deploy a new version, you just change the file name and be good. So that's something that should be done. And then also minifying or uglifying the HTML. That's relatively advanced. Some tools out there that can do that. Again, it's 25% reduction that is possible by uglifying the HTML code. So that's also something that might be worth it. So if you remember back all the different recommendations, gzipping, uglifying, cache, and everything, this could make for an amazing website. And none of the steps are, in theory, hard. It's not about completely re-architecturing the entire site. It's mostly about just thinking of a couple of general best practices and consistently using them. And then also something about the images. So some of them are not compressed, and by compressed I mean losslessly compressed. So this is, if I remember correctly, this was in two SVG files. So SVG happens to be just an XML file, and different tools leave a lot of meta crap in these SVG files. So there are a couple of tools out there that will just remove all this non-visible XML and whatever meta crap and make the files considerably smaller. So in this case, 59% without any visual degradation. So this is really completely lossless. If you look at the absolute numbers, it's 16 kilobytes that could be saved. That's why down here the bar is pretty small. So compared to the other things that have way more impact, but still in a typical build chain or build environment, this should be just an automated step. Whenever you deploy a new version, run all your images through a different tool like ImageOptim, for example, and make sure that they are as small as possible before you deliver them. And this kind of would end the machine-generated part of the speed review. And then in the next step, we would go through, or actually typically in between, so I would jump back and forth if this would actually be a real review, and just go through all these different points together and check on the live side what is going on there, and if the server is still responding slowly and stuff. So this is how the speed aspect would be addressed. So over to the final parts of my, what the web page could do better talk. Well, dealing with the dreaded offline dinosaur. There's an emoji proposal for having dinosaurs. Unfortunately, it's not yet through the Unicode consortium. So the next best thing I found was this offline dragon. So just imagine we live in 2017 or 2018, and we already would have the emoji dinosaur. Then I would have put it here, but yeah, anyway, that's as good as it gets. So the offline dragon here. So how do we do it? Well, one response could obviously be, well, we just built an app, and code.talks have done that. I found it funny in this email, it was listed under gimmicks. So that's probably, what I would describe it best. It's a gimmick. So if you have additional time, well then, for a conference, build a native app. For all other cases, probably, at least for conferences, the website would be good enough. One of my favorite XKCDs here, installing things has gotten so fast and painless. Why not skip it entirely and make a phone that has every app installed already and just downloads and runs them on the fly? And then this, oh, I felt pretty clear until I realized I invented web pages. To be fair, web pages were lacking behind native applications for a very long time, simply because they didn't have push notifications. They didn't have offline capabilities. They couldn't access things like the camera They couldn't get the orientation of the device. But slowly, if you think back 2007, Steve Jobs introducing the first iPhone and telling people the future will be web apps. And then in 2008, rowing back and saying, oh, oops, well, the future will be app stores. And then in 2015, the kind of introduction from Alex Russell and friends of the concept of progressive web apps, now that finally the mobile web has caught up. So yeah, the good news is, and this is what I wrote also in my talk description, in 2016, the year of mobile actually has started. So I guess now we can, with confidence say, well, we probably could just live with a mobile website and make not just a website, but a progressive web app. So let me introduce progressive web apps. And our poster demo child here is always Flipkart. But yeah, this is just for the intro. Progressive web apps, remember, are just regular websites. So if you happen to have a device that doesn't support all these amazing features, it's still just a website. Well, so I could just use any regular web browser and access the page, and it will still just work. It wouldn't be the most amazing experience that you could get if you had one of the more advanced browsers, but progressive web apps are still just regular web pages. So that's something that is really important. And they are available across browsers. They support fast loading, smooth animations, regular navigation, so you can move away, and it's just, the web. You're open to do anything you want. The cool new thing is, well, you can get on the home screen, which is a very important aspect for many companies. They want to have presence on people's home screens. They want to be, when people open their phone, they want to be there. They want to be back in people's minds and say, well, we're just one click away or one tap away. So yeah, you can just put an icon on a home screen. And to be fair, you could do that with, I think, even the very first iPhones that had on the Safari browser the Add to Home Screen link. But we will see a bit later on, this has become a bit more advanced recently. And then also, they can work on flaky networks, so the one that I had yesterday on the train, or even completely offline when there is no connection at all. When you're sitting in this Eurocity train and, I don't know, driving through the middle of nowhere where there's no communication tower, cell phone tower, nothing, these apps could still work. And something that is very important for a lot of customers as well is the topic of re-engagement, so customer re-engagement with push notifications. So just imagine you're a shopping website and people put stuff on in their shopping carts, and what a lot of native apps do is they send you a push notification telling you, hey, you have stuff in your shopping cart. How about you buy them for Christ's sake? And that's essentially the same thing that people want to do as well on mobile web pages, progressive web apps, sending people push notifications. And well, it's all about the progressive. The P is the most important thing of the acronym PWA, progressive. So if a browser supports the features, the experience will just get more amazing. If it doesn't, well, it stays a regular experience. So progressive web apps. The biggest introduction of, or news of progressive web apps is the service worker. You can think of service worker as being a proxy that's written in JavaScript and runs in between your web application and the web. So the web server that you talk to, and it sits in between and just mediates the communication back and forth. So the traditional way is your web application directly communicates with the web, makes API calls, loads stuff. With progressive web apps, there's always the service worker in between and can do stuff. So we will see some of this a bit later on. And for example, if for some reason this connection is gone because you're offline, you can still, from here to here, from the web application to the service worker, establish a communication. So that's something that is very important. So that's the first technical term, service worker. And the most difficult one, actually, to wrap your head around. And I still don't say that I fully understood everything, but slowly getting better at it. And then we have the manifest files. This has been around for a very long time, but yeah, it slowly started to be more useful. So you can see here, it has a short name, My Cool App. It has a long name, My Totally Cool Application. It has icons in different sizes and different types. It has a start URL. That's very important if you think of the home screen case. So if people put this app in the home screen, where should the application actually start? And then there's something cool. You have a display property where you can tell the application how it should look like. There's a lot of discussion going on, well, if progressive web apps are just regular websites, should they still have a URL or should they hide it? Should they pretend to be just like apps and not even show a URL? The good news is with this display property here, you can define that and say, well, I want it to look like a web page, so it should have the URL bar. Or you could say, well, I want it to look completely like a native application, and then you can hide it and run the thing in standalone or full screen or whatever fits best. You have a theme color and a background color to match the theme, and also this helps the browser to generate a splash screen when your application loads. And finally, you have the orientation property. So you can say, well, I'm a game developer and I need my phone in landscape. So you can already put the browser in the right orientation. So that's the manifest. So yeah, how does this actually look like when you kind of want to add an application to the home screen? When people interact with your app enough, and this enough is kind of a very fluffy term, they will see this app install banner here that tells them, well, do you maybe want to install this application to your home screen? If you decide to do so, so if you click this blue button, this is how it would look like. So you get this icon on your home screen that is completely that completely looks no different from all your other native applications, so the browser application or the phone application. It just looks like a regular app. And yeah, then when you launch it, you're just brought into this app-like experience in this case. So you can see this is a web application, but there is no URL bar at the top. It just launches full screen like or standalone like a regular native application would. But this is configurable. Yeah, what people completely hate is the widescreen. So this feeling of loading. So what the browser does with the information from the manifest, it generates this splash screen for you. So it uses a big enough icon. It uses the background color. It uses the name, obviously. So like that, you don't have people stare on a white screen when your web application loads. And something that is very important for web applications, and especially single-page web applications, in many cases, these applications have what we call an app shell. So static parts that are always there. So that's a very simple app, of course, but you can see there's always this header, there's always this menu, and then in green, in this green box here, that's the actual dynamic content. But everything else, everything is statically around it. That's just the app shell. So these kind of content shouldn't be pulled from the network every single time. It would be just nice to have it directly in the browser cache. And yeah, so that it would always be there, even if the browser is entirely offline, so that you get this nice application shell quickly loading. And then you could even have some fallback when you don't have network to maybe display the last dynamic content that was loaded and store the last n dynamic API responses or images or whatever. If you're a news application, maybe you could store the last looked at news articles or just this kind of dynamic content. And the app shell is statically always there. And then the thing is, well, what do you do when you have flaky network? So a couple of UI patterns have started to emerge. So rather than just being completely offline, wouldn't it be nice if the app at least showed some of the content, as I said earlier, if you are a news app, maybe the last n articles, or maybe the article you have last looked at, and in this case, Flipkart, the last things you looked at in this page, on this page. So there's this phone, for example. And you may notice as soon as we activate airplane mode, like now, the page kind of starts to get black and white. So the thing is, the application no longer is really online, but works offline with cached content. So some developers have started to use black and white as a UI pattern to tell people, well, what you see is now cached. It might be old. Still, as I said, not really fully adopted in the industry, and a lot of advantages and disadvantages. But yeah, this is what they have chosen, so that the user always knows, well, we are now online or offline. If you're online, you get color. If you're offline, you get just black and white, at least for the app shell. Yeah, personally, probably I don't like it that much, but this is just something to think of. It was the web, as always, but all of a sudden, we have to think of, well, there's an offline web and an online web, and maybe we somehow want to communicate to the user. If you're offline, for example, and there are links in the page, they might not work. So dynamically, you might decide, well, you could maybe strike through the links that don't work currently because you're offline, or make them just give them a different color, or disable them, or whatever. So new things that all of a sudden are possible also cause you to think of problems you didn't have when you just had the offline dinosaur. So this is just something to keep in mind. And then, well, we have obviously one of the big selling points, speed. Progressive web apps load instantly, more or less, simply because most of the content is already in the cache. The performance recommendation is always to go to get to the first paint in less than 3 seconds on a 3G connection. So if you remember back, the code.talks server took 2.3 seconds before responding at all. So yeah, there's not much time left until getting to 3 seconds. And then for repeat visitors, to make the loading of the page less than 500 milliseconds. And this can actually work. General performance requirement is always also to have scrolling at 60 frames per second, so that it doesn't feel janky. And also something that a lot of people hate, when content loads and the content jumps around. So when you have an ad that slowly loads in the background, and all of a sudden the text that you're reading jumps around, that's something that is completely non-acceptable. And then, as I said earlier, web push notifications. That's something really cool, and what a lot of people don't expect when they think of web applications. Some people have seen push notifications before, and they think, well, they only work when the browser tab is open. But here, this is not true. If the browser tab is completely closed, even if you have entirely started your phone freshly, push notifications still work, because there is some daemon in the browser that is just listening for web push notifications, just like the daemon for native push notifications. Obviously, not every web page should be able to push stuff to you. So whenever you start on a new web page, the web page asks you, well, do you want to accept push notifications, yes or no, so that you don't get spammed if you are, if you don't want to receive push notifications any longer. All right, and now the big elephant in the room. Well, where actually on which browsers can progressive web apps work? The cool thing is, well, they work on a lot of browsers already out of the box. So Chrome, Firefox, Opera, and Microsoft Edge. So at least in the developer versions of Edge, this is supported. So that's really cool. And then there are very, very strong signals that Apple are also working on adding service worker support to Safari. Apple, they don't make any public comments, but looking at some of their questions and some of their discussions, there's a high probability that they're working on it. And you can see there's a lot of green here. Being the only one that is still yellow, probably not the situation that Apple want to be in. But yeah, the good news is a lot of browsers already support this. And if you happen to have an Android phone, most probably you also have a device that already supports progressive web apps. And one quick reminder, everything about progressive web apps requires HTTPS. So this is why also code.talks are in a good position. they already have HTTPS, but also more and more browser APIs will require HTTPS in the future. So in the future, camera, geolocation, all progressive web app features like service workers, but also autofill for form, push notifications, service worker in general will require HTTPS. So that's what I said earlier. If you are still on HTTP and well, you run any kind of business, probably now is a good time to move to HTTPS. So after all this, well, how great everything is, let me actually introduce the progressive web app for code.talks. There wasn't one, so I built one. Bear with me while I quickly switch screens here. So let me switch over to here. Yep, you can see that, great. So what I did is I went to the code.talks page, used one, not even sure what the tool was called, so a tool that allows you to download an entire web page. And then I looked at the different calls the application was making, and started building a progressive web app. And the cool thing is you can just test it on desktop, but also on your mobile phones. So if you go to bit.ly/code.talks -pwa, you should see this page. So bit.ly/code.talks -pwa. You should see this page. So this is how it looks like on desktop. Obviously, we can make it look like a mobile web page here by simulating a mobile device. And by the way, a lot of people ask me, how do you get this nice device frames? This was added recently to Chrome, so if you click these 3 dots, you can just hide and show the device frame. So by default, it looks like that. If you show the device frame, it looks a lot nicer. And also you get another developer tip, you get this screenshot option here. So you can just capture a screenshot, and it will just look like that. So taking mobile screenshots has never been easier. So yeah, that's cool. So, well, why is this now a progressive web app? Well, because now it works offline, because now it has a service worker. Let me show you how this looks like. So in latest versions of Chrome, you have this, in the developer tools, you have the application tab here. And in the application tab, there is a section on service workers. And if I go there and increase the font size a bit, that you can actually see something, you can see, well, there is a service worker that is activated and is running. And it's called service worker.js. It's just a regular JavaScript file. We will see some of its contents in a bit more detail later on. But let me actually show you some of the features. So now I am online. So yeah, everything is working as intended. If I go offline, so you can simulate that by clicking this offline button here, and I now try to go to google.com, you will see there is no internet connection. If I go, however, to code.talks.de, you will see it also doesn't work. But if I go to code.talks, my own short URL, code.talks PWA, here we go. You will, ooh, what's going on? I messed it up. This one. Ooh, sorry for the URL mess up. You will see that this web page actually does work. Well, I mistyped the URL so many times that you could see that I was actually offline. So what you can see here is that's the application offline, and it still works. So that's kind of cool. It has all the regular features. To be fully honest, I didn't fix here the filter, so the filter is not really working offline. But yeah, all the other things work. Physically, if you go to one of the deep links here, it's a new web page, so it didn't cache everything offline. Offline. But at least you could have the program that now works fully offline, as I just showed you here. Something that is also cool is the add to home screen. And a lot of progressive web apps is really about the progressive stuff. So the cool thing is this even works on desktop. So if I go to the manifest here and I click this add to home screen, you can see there's this tiny gray bar that says add this site to your shelf to use it anytime. And I can say yes. It asks me for the name. It uses the name that is in the manifest. I say OK. And then you can see here, this is my browser's Chrome application folder. So you can see here, that's my Finder, and it's code.talks.app. So it looks like any native application. And I could actually put this on my desktop now, and it would work. And you can also see, if I go to a new tab, and let me activate my bookmarks. I go to here, you can see it's there. So among my other Chrome applications, it's just there. And I can launch it, and it will work. So this is pretty cool now, because now I have this application directly here on my device. And I can go entirely offline now. I could disconnect from the network. And the thing is, progressive web apps are not about mobile only. They're also about desktop, because all this technology is also in desktop browsers. So let me show you one last feature, push notifications. I need to quickly move over here to my console. So that's the application here. And I have this tiny script that will just send a push notification. And bam, there it is. That's another notification. But there it is. It tells me trending, Tom's amazing talk. Follow him on Twitter, Tomayak. So that's a push notification. And you may have noticed I have this tablet here next to me. So this tablet is also connected to, let me actually connect here. This is also connected to this web application. Just a sec until I connect. Actually, I think I had it open somewhere in the background. Yeah, it's already open. So here we go. So that's the application on my tablet. You can see if I scroll back and forth, what you see on this tablet, you can see here on the development screen. And it's pretty small, but yeah, it doesn't really show up here. So if I swipe down, you can see there's USB debugging and USB for charging. And if I now resend this push notification, you can see that it has popped up. So this is running on my tablet. And yeah, now you get the push notification again. And it's also just working on the tablet. And that's just a regular notification. It's not distinguishable from the other notifications that you have on regular Android applications. So this is this. And well, now here, obviously, I can do just the same. Let me actually put this somehow that you can see it. So now I can see my device. And if I'm doing stuff here, I can now simulate, for example, here on this device that I'm offline. Offline. I reload. So you can see it still works. And yeah, it's just working as any native application. And I'm actually here, yeah, not connected to the internet. So the push notification just goes through the USB debugger. All right, so let me jump back to my presentation. You've seen the app. It's open source and on GitHub. The demo, the deep link is bit.ly/code.talks-pwa. The actual code is yeah, under my GitHub username, tomayak/code.talks-pwa. So that's it. And yeah, what I've seen so far is I've demoed you the application on mobile and on desktop. And even on desktop, you have things like add to home screen. You have the push notifications. You have offline support. So that's pretty cool. So how does this work? Well, the service worker is the most important thing. And this conference is called Code Talks. So let me very briefly talk about code. So no chance to really go into much detail in a couple of minutes, but for a service worker, there are a couple of events that are crucial. So in the service worker.js file, you listen to events. And the first event that you need to listen to is the install event. So you have an install event that has this wait until function that you can call. And upon starting the application for the very first time and installing it, it will cache a couple of files in its static cache file. So that's what I said earlier around the application shell. So I've made the application store its CSS, the logo, the bootstrapping JavaScript and stuff. So that's my app shell that I'm storing here for this application. And you can see a lot of this code is actually just debugging. So this entire block is just debugging. This entire block is just debugging. So if you look at the actual code, it's self-add event listener install event wait until, and then it opens the cache for static content. So that's a static cache name. And then it has it. So it's all promise-based here. And then we return another promise that would add all static files. So static files is just an array with all the static files that I want to store in my application, my CSS, my JavaScript, my program.html, core document. And then the next thing is just, well, again, debugging. And I directly use the service worker by skip waiting here. So that's the first event, install. The second event is activate. So once the service worker is installed, it needs to get activated. So that's step 2. So again, this is all living in service worker.js. Add event listener activate. Then you have the activate event. Some debugging. Again, you have this wait until. So all these operations may take a bit. So yeah, you need to wait until they're ready. And then in the activate task, what you typically do is some housekeeping, because a static cache may still change. So sometimes code.talks may want to change some of their CSS, so they need to clean up some of the caches. So you can see here from my caches, I get all the keys, and I iterate through all these keys and look if the key name is one of my allowed ones. So is it static cache name or is it dynamic cache name? So constants that I've put in place. And if they're neither, which means they're old caches, I just delete the cache entirely. And once this is done, once this housekeeping step is done, I can then return and claim my clients, so the web page that has installed and activated the service worker. So that's the second event. The most important event, actually, or arguably most important event, is the fetch event. So fetch means whenever the web page requests data. So if you remember back in my diagram, it was this web application, then there was the gear symbol for the service worker, and then there was the web. So the fetch is whenever traffic happens across the service worker, when the service worker gets some information from the network or from the cache. So well, you have, again, self-add event listener. For the fetch event, you get a fetch event back. I can extract the request URL. And then I have some super basic routing here. The code.talks page was organized in a way that /assets, well, held all the assets, as the name suggests. So if the URL is something with /assets, then I use a strategy that is called get cache first response. So that's important. There's different ways of retrieving content. You can go through the cache. If the cache has the data, you return it. Or you can go to the network. If the network fails, then you can fall back to the cache. That's a second strategy here. So I decided for my assets, so the more static things, to use a cache first policy. And for everything else, so the core document, other more tiny elements on the page, I use a network first response policy here. And that's essentially it. So you decide on a cache strategy for each of your assets. For example, for the program, for the actual schedule, it may be important to have the content as fresh as possible, whereas for the assets, it's not that important to have always the latest content. All right, and then the final event is for push notifications, the push event. So you can see a pattern here already: self, add event listener, push, push event, I debug stuff. And then you have, again, this wait until. And the current limitation with the version of push notifications that I'm using is they don't actually hold any payload. You just get a ping that there is a notification that you want to send. So what I do here is I just fetch from some simulated API a push message, push message.json, and pull the actual data down. And once I have the data, well, I parse the JSON, and then you have this self.registration show notification that would show the push message's title plus the actual message. And then just some fallback in case something happens. So if this API doesn't respond, if push message.json is down for some reason, that you could still show, well, there was some new push notification, so some fallback. But in general, what this would display is, well, the thing that you have seen so many times now, this one. So let me get back to the slide. So these are the core events that you want to listen to. And that's the end of my talk. So thank you very much. And please try my PWA. That's the URL. And thank you so much for your attendance. Thank you.